The measure of intelligence of a group of people is assumed to be approximately normally distributed with mean 102 and standard deviation 14. We're told that Tom's IQ denoted by XT is at the 98th percentile of the IQ distribution of the group of people. And based on that information, we need to find the value of XT. Okay, so first notice that XT is Tom's IQ score. Okay, these are his IQ points. And we need to find that based on the fact that the mean, okay, from a group of people is 102 and the standard deviation is 14. So how do we relate all these numbers? Recall that we can use the equation Z is equal to x minus mu divided by standard deviation. Okay? So notice that x in this case is going to be the unknown, the Tom's IQ score. And we need to find the value of the z in order to solve for the unknown, right? So basically the value of the z will be the value that corresponds to the 98th percentile. So we're going to mark it as 0.98. Okay, 98th percentile in decimals is 0.98 because you divide 98 by 100, you get 0.98. And we're going to find this value in the z table by finding the probability that matches the 98th percentage, the 98th percentile. So there's a z value that corresponds to the 98th percentile in the z table that we're going to find. So this is equal to the xt, Tom's IQ score, which is this guy here in the equation. This is the standard equation, standard normal equation. Okay, so we can mark this as Tom's IQ score. Okay, so instead of the x, we're going to just replace it with xt minus the mean, and the mean is what? 102. And that is divided by the standard deviation, which is given as 14. So now let's find the z value corresponding to the 98th percentile. So to find the z value, we just look at the normal table. And notice that the 98th percentile means that we're nearly at the 100%, right? We're nearly at the probability of 1, basically. Right? So that's why we're using the positive z table and not the negative one, right? Because the positive z table, as you can see, starts with a probability of 50%, which matches the decimal of 0.5000, right? So we need to find the 0.98, right? Because recall, here we're trying to find 0.98, right? Notice in this table, the z values are in the first column and in the very first row on the top. So we have to find the probability of 0.98 and then match it against the z value in the column and row that meets at that 0.98. Okay? So where's the 0.98? Let's find that. Notice that we're getting closer and closer here to 0.98. There it is. So it looks like this is greater than 0.98, but this is barely smaller, right? It's about 2/10,000ths away, right? This is 3/10,000ths away, but this is only 2 away. But we'll think of it as a midpoint between these two values. Now let's think about what the z value is for the value between these two values, right? Because we want precisely 0.98, right? No greater, no less. So notice that this row is the z value of 2.0, right? So let's mark that 2.0, but that's not everything, right? Because 2.0 is just this row. But we also have to think of the column corresponding to either one of these two values. So this column gives us a z value of 0.06, right? But this column gives us the z value, if we trace it up, gives us the z value of 0.05. So naturally, if we're talking about a value in between, we have to think of 0.055, right? Something between 0.06 and 0.05, right? 0.055. So we got to add that to the 2.0 the value of the z in the row that we had, right? So we're going to add that 0.055 to the row value. 0.055. So as a result, when you add it, it's going to be 2.055. There you go. So this is the complete z value. Okay? So we can say 98th percentile. This is the z value corresponding to the 98th percentile. So basically, all the z values greater than this value correspond to the remaining 2% that are greater than this, right? The remaining 2%. So all the values combined for the probability values that you see beyond that is the remaining 2% of the probability, taking the area of the normal curve. Right, so let's go back now that we found that value, 2.055. So we can put that instead of the z value here. Right, so this guy is equal to 2.055 based on what we just found. So that's equal to the unknown that we're trying to solve for minus the mean over standard deviation. Now, of course, this is just simple algebra. Multiply both sides by 14. That will eliminate the 14s on the right side. And I will just switch equations for now. Switch sides of the equation using the symmetric property of equality, right? So minus 102 is equal to this guy, 14 times 2.055. This product is equal to 28.77. Okay. And now finally, all you have to do is just add 102 on both sides, to both sides, and then you will have the final answer. 131.5.